What is the decimal equivalent for 1F? 1F is the hex number. Okay. So what will be its decimal number?
16.
1F is the 1F is a hex number. 1F. 1F is not shown here. So 1F is a hex number. What is its decimal equivalent?
115.
16.
How? Suppose I have a 1F as a hex number. What would be its equivalent decimal? If you see F is 15, right? So 1F
115.
should be. So if we just go on counting this, you will understand. Okay, 21, so on up to, I think 32 or 31.
31. 31,
Yes,
sir.
31.
31, sir.
सर आवाज नीट येत नाही.
Hello, 1 second. Okay, is it okay? Hello.
Yes sir.
Okay.
Yes sir.
So these were the hex numbers. You will learn about hex numbers later. Okay. The next thing is convergence from binary to decimal. We have seen this yesterday, how to convert binary number into decimal. For that, we should know the positional weights, right? While converting any number into decimal, we just have to find out the base. Suppose if you have binary number and we want to convert it into decimal, the base is 2. If we have octal number, then base is 8. If we have hex number, then base is 16. So the process is the same, addition of multiplications. Okay, so multiplications of the numbers. Suppose if I take this binary number 10101, so the positional weight of the first LSB bit, this is lowest significant bit, right? So the positional weight of this bit is 2 raised to 0. The next bit has positional weight 2 raised to 1, and so on up to 2 raised to 4. So we just have to multiply this. I'll just mute all. Oh, I'm getting some noise here. Okay, so 2 raised to 0 multiplied by 1, then 2 raised to 1 multiplied by 0, 2 raised to 2 multiplied by 1, and so on. And then add all these numbers. So this is very easy. Then we have conversion from octal to decimal, we have discussed yesterday. So the changes in the base. In binary, the base was 2. In octal, the base is 8. So rest of the things are same. But here the example consists of both integer value and fractional value. So when we do conversion of only integer value, we have powers of 8 in positive. When we have fractional number, we have negative. Okay, suppose I have this fractional part here, 0 and 6. So for that we should use these two positional weights. One is 8 raised to minus 1, and that is 8 raised to minus 2. Okay, and we know that the rest of the things like multiplication of these digits by the positional weights. Then we saw the conversion from hex to decimal. The same thing is here again. Instead of base 8, here the base is 16. Okay, so here the conversion which we have discussed yesterday. Now let us move to the next part. This is the important part because there are so many conversions. If you see, there are 4 number systems in total: binary, then octal, decimal, and hex. So we just have to see the way which by which The numbers are getting converted from one number system into another number system. So whenever we want to convert any number system from suppose decimal to binary, there are certain rules. So while converting any number into decimal, the rule was addition of multiplications. Okay, so the first three examples we have seen that there were additions and there was addition of multiplications. Okay, so binary to decimal, addition of multiplications, octal to decimal, addition of multiplications, then hex to decimal, addition of multiplications. Only change is in the base values. Okay, so that is the change. Now we'll just move to the next part, that is conversion of decimal to binary, opposite of binary to decimal. So how to convert any decimal number into binary? The first method is double double method. So this method is called as a double double method. So here the number to be converted is 52. Okay, so we just go on dividing this number until we get the remainder 0. Okay, quotient 0, sorry. So 52, the first of all we'll divide this 52 by 2 because we want to convert decimal number into binary number. When we convert decimal to octal, we should divide by 8. When we want to convert decimal to hex, we should divide it by 16. So remember this, that whenever we want to convert any number from decimal to binary, we should divide by 2 successive divisions. Okay, divide by 2. And when we convert any number to octal number, then we should divide it by 8. Okay, for dividing converting from decimal to hex, we should divide it by 16. So this rule we must remember, right? Okay, so 52 is divided by 2 successively. So we go on dividing 52 by 2. So answer is 26. When we divide 52 by 2, answer is 26 and the remainder is 0. Okay, then 26 is again divided by 2. We get the result 13. Now here a remainder is also 0. Now again we will divide this 13 by 2. So when we divide 13 by 2, the quotient is 6, remainder is 1. Okay, 13 by 2, quotient 6, remainder 1. Now 6 divided by 2, quotient 3, remainder 0. 3 divided by 2, quotient 1, remainder 1. 1 divided by 2, quotient is 0 and remainder is 1. Okay, now we just have to write all these remainder values from bottom to top. Okay, so 110100, so 110100, this is the answer. So this method is called as a double double method. Okay, so there is a slight difficulty in writing on this. Okay, try to understand. So this is double double method. So I'll move to the next part. In the next part we have both integer as well as fractional part. So in the previous example there was only integer part, so 52 was converted into binary number format. Here we have both integer as well as fractional part. So here we have to use two steps. The step one is separate out the integer and fractional part and divide the integer part successively by 2. Okay, so successive division by 2 method. So here the same procedure is followed again. 163 is successively divided by 2. First of all, divided by 2, we get the answer 81. Remainder comes as 1. Then 81 divided by 2, quotient 40, remainder 1, and so on. So we should do this until we get quotient 0, or the last divisor is 1. So we have divided all these numbers by 2, and we should do this until we get the
Hello.
quotient 0. Hello.
Oh,
Okay, so remainder is, we know remainder, how to define find out the remainder. So 163 divided by 2, we get the answer 81, and so on. So same thing is followed, and finally we get the remainder values like this, and we have to write down these remainder values from bottom to top. Okay, so this part converts our integer part into binary. So we just have to write down these numbers. So I think these numbers are written here. Okay, 1010 up to 11. So this will give us conversion of integer part into binary. Now how to convert fractional part? So while converting fractional part, we have to multiply the number by 2. Okay, so this is successive multiplication. So here we have the fractional part, that is 0.875. 0.875 is multiplied by 2, we get the answer 1.75. Now we just have to use this integer here. Okay, the fractional part is used in the next multiplication, and the integer part is used as a we can say that as a reminder here. Okay, so 1.75, it is then 1 is removed from it, written on the right side. 0.75 multiplied by 2, we get answer 1.5. This one is written here. So 0.5 multiplied by 2, we get answer 10. So the next all multiplications are going to become 0. Okay, so we should stop here, and the final answer is 1. Now write down all these values from top to bottom. So we have 1 1 1 here. This is the conversion of fractional part. Okay, so in this way we can convert any binary number into sorry, any decimal number into binary format.
Binary number.
Okay, so are there any doubts? Anybody
No,
has
sir.
any doubts? Okay,
No, sir.
so let us move to the next thing then. Conversion of octal to binary, then hex to binary. So we are following the path like this. First of all, we have converted all numbers into decimal, that is binary to decimal, octal to decimal, hex to decimal. So that is conversion of all other number systems into decimal. So we have seen all these 3 examples. Then we are going to convert all other number formats into binary. Okay, so the first thing is decimal to binary, we have just seen this. The next thing is conversion of octal to binary, and then hex to binary. Okay, so octal to binary and hex to binary, these are very simple things. We can easily do this. So I'll give you one hint how to do this. There is a one rule called as 8421 rule. Okay, 8421. Now this, out of this 8421 rule, when we do octal conversion, we should use only 4 to 1 rule, and when we'll do hex to binary, at that time we will use 8421 rule. So remember that while doing the conversion of octal to binary, we should use 4 to 1 rule. Now what is 4 to 1 rule? Suppose I have 1 1 1. Okay, so this 4 to 1 rule is like this, 1 1 1. So if we add these all things, so this 1 is below 1, 1 is below this 2, and this one is below 4. So all 3 ones are present, so we must add 4, 2 and 1, so we get answer 7. Okay, suppose I have 0 1 0, so only digit 2 is present, so answer is 2. Or if I have 1 0 1, then two digits are present and one is 0. So 1 is present below 4 and 1, so I can add 4 and 1. So 4 plus 1 is 5. Okay, so same thing can be used here. So here we are going to convert 367.52 octal number into binary. So we just have to replace these octal numbers by their equivalent binary numbers. Okay, so how will you represent 3 from this 4 to 1 rule? How to make 3? For that, the combination will be like this. Now we cannot have 4 here because the digit here is 3. So 2 plus 1 can become 3. So we just have to put 1 below 2 and 1 and 0 below 4. So the equivalent binary of octal 3 is 0 1 1. Similarly, 6 can be represented like this. 4 plus 2 is 6. So 1 1 and 0. Okay, 7, 4 plus 2 plus 1, that is 7. So we should have all ones like this. Then dot 5, 4 plus 1 is 5. So 101. Okay, then 2. So there will be 2, only one digit is there. So 0 1 and 0. Okay, so very simple conversion of octal to binary. So conversion from octal to binary and hex to binary is very simple. Now see, you will see conversion of hex to binary. Now in octal to binary we had used 4 to 1 rule. Now here we will use 8 4 to 1 rule. Okay, same rule you can use while converting binary to hex. So reverse of binary to octal and binary to hex, same thing can be used. So 8 4 to 1 rule. Suppose I want 4. How will you make 4 from this? I just have to put 1 below 8, rest will be zeros. So 0 1 0 0 is 4. Now what is B? What is the equivalent decimal of B? Because all these numbers are decimal numbers. So B, equivalent of B is how much?
11.
11. Okay, so how will you make 11 from 8 4 to 1? So I should take 8 2 and 1.
8
So
to
8 plus
1.
2 plus
8
1
to
is
1.
11. So 1 0 1
1 1.
1
1.
1.
Okay, so 1 0 1 1. Then A is 10.
10.
Okay, A is 10.
8 plus 2.
8 plus 2. So 1 0 1 0. Okay, C is 13. Sorry, 12. C is 12. So how to make 12?
8 plus
8
4.
plus 4. So 8 plus 4 is 1 1 0 0.
0 0.
Okay, so this is the conversion of hex number into binary. The same thing can be done for numbers like this. It has both integer part and fractional part. So we just have to separate out the digits. Now the first digit is 3, then A, and just replace all these digits by their equivalent binary number. Okay, and it is very easy. In case of octal we were using 4 to 1 rule. In case of hex we should use 8 4 to 1 rule. Now here 3 can be taken as 3 2 plus
2
1,
plus
so 0
1.
0 1 1. A is 1 0 1 0, 9 is 1 0 0 1, and so on. Okay, so I think it is very clear to you. Okay, so we have seen conversion of decimal to binary. So while converting decimal to binary, the rule is successive division by 2. If it is only integer number, successive division by 2, find out the remainder, write those remainder from bottom to top. And if you have a fractional part also, then why for converting fractional part, successive multiplication is there. So integer part successive division, and fractional part successive multiplication. Okay.
Multiplication.
Octal to binary and hex to binary are simple. Octal to binary 4 to 1 rule, hex to binary 8 4 to 1 rule. Just replace each digit of octal and hex by their equivalent binary groups. Okay. Now, how to do the binary to octal conversion and binary to hex? These are just reverse operations which we have done here. So here octal to binary was converted. The same thing can be done for binary to octal. So suppose I want to convert this 011, this is a binary number, to octal. So what will you do? You just reverse the operation. So one example is here. So here we have 110101 like this. This code is their binary code, and we want to convert it into octal. So while converting any binary number into octal, we should make group of 3 binary digits. Okay, so 3-bit binary group is required. So how will you make the group of 3? So we should start from this point, okay, and start making group of 3 digits like this. Okay, so we should start from this point. So the first group is 101, second group is 110. So 101 is nothing but, if we use the 4 to 1 rule, we know that if I have code like this 1 0 and 1, so I should take 4 and 1. So 4
1.
plus 1 is 5. So 110 is 6. 101 is again 5. 010 is 2. Okay, 0 1 0 is 2. Very simple. Now the next thing is binary to hex. So what will you do while converting binary to hex? Here we need to make a group of 4 bits each. Okay, so how will you start? We should start from this point. Okay, so start making group of 4 digits each. Okay, so when we have only when we have less than 4, we just add zeros at that place. So we had just only 2 digits here, so we have appended 2 zeros here. Okay, to make a group of 4 digits. Now 1011, what is the hex equivalent? Use 8421 rule. So 1 0 1 1. So 8 2 1. 8 plus 2 plus 1, it is 11, and 11 is represented by hex B. Okay, we should not write 11 here, because 11, when we represent 11 in hex number, it will treat 1 and 1 separately. Okay, so 11, whenever we have decimal 11, it should be written as B, otherwise it will take 1 1 separately. So the next is 1 1 1 1. All ones are there. So 8 plus 4 plus 2 plus 1 is 15. So 15 and its equivalent hex is F. Then we have 2. Similarly, we can convert 0 1 1 1 into 7 and 1 1 0 0 into C. Now if you see, there were only 2 digits. So you have to put zeros after 1 1, not before 1 1. Okay, this is wrong, because this will change the.
Hello.
Hello. Okay, so we have a limitation of 40 minutes. That's why there was some, in interference. Okay, so we have seen the conversion. from binary to hex. Now octal to hex. Now this is interconversion from octal number into hex number. So how to do this? Now suppose I have octal number. This is octal number, remember, because it has 1, 2, 4, 5. So octal number into hex is very simple. So first of all, represent each octal digit by its equivalent 3-bit binary code. Okay. So 1, 2, 4, 5. 1 is shown by 001, then 2 is by 010, 100, and 110, because 1, so 001, 010, these are the binary equivalents for these octal digits. These are octal digits. Now once we have this code, we just have to regroup these bits into group of 4 digits, group of 4 bits each. Okay, so what I have already 110 here, that is 3-bit. I should take this 0 here to make it 4-bit group. So 0110, so I am left with 10 here. So I should bring these two bits together, so it becomes 1010, and finally 001 and 0. Okay, so while converting octal to hex, we have 3-bit groups of binary digits. Then distribute those digits into group of 4 binary digits and represent each those 4-bit binary code into hex using the similar principle of 8421 rule. Okay, so 0010 is to 1010, that is 10 represented by hex number A. 0110 is represented by 6. So this is very simple. So the first thing is convert first of all octal number into binary equivalent, then regroup those binary digits into group of 4. Okay, and replace the group by equivalent hex number. Okay, so this is the conversion of octal to hex. Now we can do the reverse conversion of hex into octal. So how to do this? Reverse operation. Every hex number is represented by its 4-bit binary code. Then divide that 4 group binary codes into 3 bits and represent each 3-bit group by the equivalent octal number. Okay, so that is our next example. Here we are going to convert octal to hex and here hex to octal. Okay, so every hex is converted into equivalent binary 4-bit binary code, because hex can be represented by 4-bit binary and octal can be represented by 3-bit binary. So b is 11, so 8 4 2 1 rule, 8 plus 2 plus 1, that is 11, and so on. All these hex numbers are represented by their equivalent binary numbers. Then uh, redistribute these groups. So how to redistribute? Start from this point. This point is important. We should not start from left side. We should start from this point, and for integer move to the left side and for fraction move to the right side. Okay, so make a group of 3 bits like this and so on. So we are left with 111, 011, 110 and 101. So 111, its equivalent octal is 7, 3 and so on. So the important thing is, first of all, convert hex into 4-bit binary, regroup these 4-bit into 3-bit, start from point, this point is important, start to left and right from this point while making the groups. And once we have group of 3 bits each, represent those 3 bits by equivalent 4-to-1 rule. You can use here 4-to-1 rule. Okay, because in 4-to-1 rule we cannot go beyond 7. So 4-to-1, that is 7, not more than that. So this code is octal code. Okay, so are there any doubts? I think, are you clear?
Yes, sir.
If you have any doubts, you can ask me. Everybody's here.
Yes,
All
sir.
clear, sir. All
Sir,
clear.
yes, sir.
Okay,
Clear.
okay. So the next part is decimal to octal, but we are short of our time. I can just have a meeting of just 40 minutes, and I'm already at 37 minutes. I may not complete the next part. So if you have any difficulties or anything to be shared with me, you can just tell me. Otherwise, we are going to have our next lecture on Wednesday, according to your timetable, Wednesday and Thursday morning. Yes? Any doubts?
No, sir.
No, no, sir. No, sir.
Okay, so
No, sir.
okay, so shall we stop?
Yes.
Yes, sir.
Yes.
Okay, thank you.